Hello, welcome to this lesson on the Tiller series. Please don't forget to like the video and subscribe to the YouTube channel. You know that in our previous video we talked about the Maclaurin series, and we said the Maclaurin series is the Tiller series which is expanded about the point x equals 0. So with the Tiller series, we can do our expansion about any point that we want to. So the Taylor series of a function s expanded about any point x naught is given by f of x equals this function that we can see here, and we can decide to expand this, right? So when we expand this function, we are going to get f of x naught then plus f prime of x naught times s minus x naught plus what we can see here and plus this, right? So know that this happens to be the first term, the second term, the third term, and the last term. That means in find the Taylor series, what you are interested in is to know the particular function and a point about which we are expanding the Taylor series. So with this quick knowledge, let's take an example. So the question says, by considering the Taylor series for the function f of x equals x exponent -1 about the point x equals 1, we are to calculate the values of the constants a and b in this expansion f of x equals 1 minus a times x minus 1 squared then plus b times x minus 1 cubed going, right? So the most important thing here is to find for the Taylor series of this particular function about this point. So let's do that. So we have our function f of x as x raised to the power -1, which is the same as 1 over x. So we will be truncating our expansion at the fourth term because we are comparing it to this expansion here, and this ends at the term containing s minus 1 cubed, so we will also want to end there. So that means we are going to use the Taylor series formula up to the term containing the power 3. So note that because we are doing our expansion about the point x equals 1, it means our x naught is 1. So from the formula we have to find f of x naught, f prime of x naught, f prime prime of x naught, and f prime 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 of x naught too. And x naught is 1. So you know f of x is f raised to the power -1. So that means f of 1 will be 1 exponent -1, which is still 1. Then f prime of x is going to give us -1 over s squared, right? I hope you know that because we have s minus 1 here. So when you find the derivative of this, you are going to get -1 times s minus 1 minus 1. This gives us -1 over s squared. So when you put in the value for our s naught, which is 1, we also get -1 for this. So finding the second derivative, we get this. Putting in the values, we get this. Finding our third derivative, we get this. Putting in the values gives us this here. I hope you get it. Alright, so after doing everything, we have the values for f of x naught, f prime of x naught, this and that. So we can substitute that into this formula to get our expansion. So making that substitution, you are going to get f of x will be equal to 1 minus s minus 1, then plus 2 over 2 factorial times s minus 1 squared, then minus 6 over 3 factorial times x minus 1 cubed plus what we have there. So expanding this further or simplifying it further gives us what we can see here. And this happens to be the Taylor series for our question, truncated at the fourth term. I hope you get it. Alright, so after finding that, you realize that the question was like, um we should calculate the values of the constants a and b in the expansion. So by comparing it to this expansion, you're supposed to find a and b. So we had this to be our answer, and you're supposed to make comparison between these two. So you realize that making comparison between these two, the coefficient of s minus 1 squared here is 1, and that here is negative a. So that means since you are making comparison, a has to be negative 1, so that this will be negative negative and to give us positive. So that means our a is negative 1. And when it comes here to realize that our b here is negative 1, the coefficient of x minus 1 here is negative 1. That means this b here also has to be negative 1. So this our b is also negative 1. So this solves the question. Okay. So you can try to find the Taylor series of ln x about the point x equals 2 to help you understand the Taylor series very well. So thank you very much, and I wish you all the best.